Welcome to this lesson video. Today we'll be looking at differential calculus. Now today's lesson will focus mainly on how to differentiate given functions. We are not going to look at first principle and the polynomials, which is the cubic function. Today we'll be looking at strictly the rules of differentiation. Let us start. Rules of differentiation. Now we have few rules of differentiation. The first one is the general rule of differentiation, which is the power rule. Now whenever you see this notation, this simply means the derivative of a certain function. A function is represented inside this square brackets. Let us look at the examples. Now before we look at the examples, let us look at this rule. It's saying the derivative of a variable raised to the power number, which is a real number. The derivative of that function or variable, we are going to take this power n, we multiply it with our variable or the coefficient of the variable, and then the very same power n we subtract 1. Now let us look at the examples. Suppose you want the derivative of this function. The derivative of this function f of x this power 2 will be multiplied by the coefficient of x, which is 2 multiplied by 1. So we have 2x, and then the very same 2 we subtract 1. Then simplifying further, we have f of x 2x to the power 1. So this is the derivative of x squared. The derivative of x squared is equal to 2x. Let us look at more examples. The derivative of x to the power 3. Then we also look at the derivative x to the power 1 over 2. We look at the derivative of x to the power negative 1. The first one, the derivative of x to the power 3. Don't be surprised. G prime x is the same as the derivative 2 negative 1 over 2. The derivative of x to the power negative 1, it's negative 1, x to the power negative 2. So this is how we apply rule number 1 of rules of differentiation, which is our general rule. We also say is the power rule. Now let us go to the next rule of differentiation. Rule number 2, the derivative of a constant is equals to 0. Now whenever we derive a constant, or let's say a number which doesn't have a variable, actually let me say when we derive a function without variables, the answer is 0. The derivative of 3 is equals to 0. Derivative of 2 is equals to 0. derivative of pi, remember pi it's a constant, is equals to 0. Derivative of -1 is equals to 0. So that is rule number 2, which states that the derivative of a constant is equal to 0. Let us go to the next rule of differentiation. Rule number 3. The derivative of a constant multiplied by a function is equal to the constant multiplied by the derivative of the function. Now this is our equation. Suppose we have a function which is multiplied by a constant. We simply separate the function and the constant and we derive the function after finding the answer. After finding the derivative of a function, we multiply by the constant. Now for example, suppose we have this function. The derivative of this function, we start by separating our constant. This is our constant, this is our function. Then we derive so we have 3. The derivative of x squared, it's 2x. Then from there, 3 multiplied by 2, it's 6x. The derivative we separate the constant with the function. We derive. Then we find the derivative of x cubed, which is 3x. Seven multiplied by 3 is 21 x squared. Let us look at more examples. Go ahead, pause the video, find the derivative of the following numbers. Now the first one, the derivative of this, it will be 1 over 2. And then we have 2 over 2x, and then this will be 1x. Let me quickly show you a trick on how to multiply a fraction in a whole number. Now suppose you want to multiply 2 and 3 over 2. It's simple. Now what you need to do is that you simply take the whole number multiplied by the numerator. The denominator will always be part of the answer. So the denominator that you see here, you simply put over 2, and then 2 multiplied by 3, it's 6. And then our final answer is 3. You can go ahead and punch this on a calculator. You will see that the answer is equals to 3. Four over 3 multiplied by 2. this denominator will be part of the answer, so you simply rewrite this. 4 multiplied by 2, it's 8. So this is what I did. Half multiplied by 2, it will give you 2 over 2. 2 over 2 is equal to 1. Now the next one, the derivative, this one actually. The derivative, you have 3 over 2. The derivative of x to the power negative 1 is negative 1 x to the power negative 2. And then from there, we have negative 3 over 2 x to the power negative 2. The last one, negative 3 over 4. The derivative of x to the power negative 2 over 3, it's negative 2 over 3 x negative 5 over 3. So negative and negative, we have positive, so we have 6 over 12 x to the power negative 5 over 3. One over 2 x to the power negative 5 over 3. Now before we go to the next rule, let me quickly show you a trick on how to multiply a fraction in a fraction. So suppose you have 2 over 3 multiplied by 3 over 2. Now how do you multiply two fractions without using a calculator? Now it's simple. Numerator and numerator, denominator and denominator. 2 multiplied by 3, it's 6. 3 multiplied by 2, it's 6. And then your answer will give you 1. X over 2 multiplied by 3 over y. So numerator and numerator is 3x over 2y. Another trick I want to show you is that suppose you have any fraction, it may be positive or negative, and then you are subtracting with 1. So let's say we have 1 over 2 minus 1. How can you quickly do this without using a calculator? I'm accommodating those who are taking tertiary physics, which is in college or university. Now 1 over 2, how can you express 1 in terms of this denominator? 1 over 2 minus 1, 1 is the same as 2 over 2. Now in this case you can see that we have common denominator. We simply take one denominator and then we subtract our numerators. So 1 minus 2 is simply negative 1 over 2. Let us try it one more time. Four over 3, let's say negative 4 over 3 minus 1. So it's negative 4 over 3 minus 3 over 3. Then we can see that we have common denominator, so negative 4 minus 3, it's negative 7. Let us quickly go to the next rule of differentiation. Rule number 4 of differentiation. Now it has to do with the sum and difference. Now rule number 4 says that the derivative of the sum or difference is equals to the sum or difference of the derivatives. Now let us quickly explain this. Now suppose we have this function 3x squared plus 1. Now you consider this as our f, this as our g. The derivative of this function plus the derivative of this. So the derivative of 3x squared is simply 6x, and then the derivative of a constant is 0, so the derivative of this function is simply 6x. Let us look at another example. Y is equals to negative 7x to the power 2 minus 3. The derivative of this, it's negative 14x minus 0, which is equal to negative 14x. The derivative of h of x, it's 12x squared plus 4x minus 0. This will be 12x squared plus 4x. Now go on and try to work out these derivatives. Now the first one, the derivative, we have x to the power 3 plus 6x squared plus 6x. We are done. The derivative of the second one, we have 18x plus 14. We are done with this question. Let us look at different types of functions. Now suppose we have a function which consists of a binomial or a bracket. Then we are looking for the derivative. Before we derive this, we need to get rid of the bracket. We need to standardize. So standardizing, we start by expanding. And then x multiplied by x is x squared. X multiplied by 2, it's 2x. X multiplied by, actually let me show you how to do this. X multiplied by x, it's this. X multiplied by 2x, x multiplied by 2 is 2x. 2 multiplied by x, it's actually 2x, and then 2 multiplied by 2, it will give us 4. And then from there we have x squared. We can see that we have like terms, so 2 plus 2 is 4x plus 4. Then from here we can apply the rules of derivative. So we have 2x plus 4. So you can see that we start by simplifying. Then from simplification, we apply the rules of derivatives. Another type of a function we should look at is this one, whereby our variable is on the denominator level. Before we can apply the rules of derivatives, we need to take this denominator to numerator level. So we have 1 multiplied by, instead of divide by, x negative 2. Now what happens is that when we take this term to the numerator level, the sign of the exponent will change. If it was negative, it will change to positive. If it was positive, it will change to negative. So in this case, it was positive, it's changing to negative. Now from here, we can see that our constant is 1. So we apply that rule of derivative of a constant and a function. So the derivative of x to the power negative 2, it's negative 2 x to the power negative 3. Now in this case, since our question, the variable was on the denominator level, we need to take it back to the denominator level. But before we do that, we need to multiply. 1 multiplied by negative 2, it's simply negative 2 x to the power. Then from there, we need to take back this to the denominator level. So taking it back, we are left with negative 2 on top over x to the power 3. So this is the derivative of the given function. Another function we should look at is the one which involves a radical, square root. Now before we can do this, we need to simplify the square root sign. Now root sign is the same as 1 over 2. Now check what happens here. Suppose you have this term. We all know that the root sign, we have 2 here. Then we look at the exponent. We check the exponent of the term inside the root sign. We have 1. So what happens is that when we want to remove this root sign, actually not to remove, to write it in an exponent form, we are simply going to take this power 2. It's going to be divided with this exponent, and then we'll remove this root sign. So if suppose we have cube root of x to the power 4, this is the same as x 4 over 3. There is a way to prove this using your calculator. You can punch any number, let's say 4 to the power 3 over 2, and then also punch square root of 4 to the power 3, you will see that the answers are the same. So back to our question, square root of x is the same as x to the power 1 over 2, and then we simply rewrite this, and then we find the derivative. We have 1 over 2 x power negative 1 over 2 plus 2x. Now since our question is having a radical sign, we need to try to leave our answer in a radical form. Now 1 over 2 multiplied by x to the power Negative 1 over 2 is the same as 1 x to the power negative 1 over 2. Remember the trick I showed you earlier in this lesson video. Now in this case, we need to take this to denominator level in order to have a positive exponent. So simplifying furthermore, numerator will be left with 1 over 2x to the power 1 over 2 plus 2x. Furthermore, we have 1 over 2. Now we can put the radical sign plus 2x. This is your derivative. My next example is based on 2015 November question paper, which is paper 1. Derivatives. We all know that the first question, it's always the first principle. But remember, this lesson video is not based on first principle. So we go on and look at the questions whereby we apply the rules of differentiation. Now we need to derive this function in terms of x. Now how do we do that? We start by simplifying. Remember, we need to simplify the brackets. So we have y x squared minus 1 over x squared 1 over x squared. Then from here, what is x squared multiplied by x squared is x to the power 4. Remember the rules of exponents. X squared multiplied by negative 1 over x, it's simply negative x squared over x squared. Negative 1 over x squared multiplied by x squared, it's 1 over, no, it's x squared over x squared. Negative 1 over x squared multiplied by negative 1 over x squared. Negative multiplied by negative is positive. Then we have 1 x to the power 4. Simplifying furthermore, we have this will be 1. This x squared over x squared is simply 1. Negative 1 actually. Negative 1 again. 1 over x to the power 4. From here we have x squared negative 2 plus 1 over x to the power 4. Now remember, we don't want the brackets, and we also don't want a fraction. So we have 1 multiplied by x to the power negative 4. Now we can apply our derivatives. No, actually there's a problem here. This is power 4, power 4, power 4. So we have 4x to the power 3 negative 0 plus negative 4 x to the power negative 5. So the derivative, we have 4x to the power 3 minus 4x to the power negative 5. And then normally I like to leave this in a fraction form like this. So this is our final answer. Our next question, based on the very same question paper, is this one. Now we need to simplify first. Dx. Now this is an identity which it's simple. What you must know is that x to the power 3 minus 1, when we factorize this, we'll always get x minus 1, x squared plus x plus 1. all over x minus 1. There is a lesson video whereby we talk about identities of vectorization. That is grade 10. dx, actually, before we continue, we can see that this and this will result into 1. Now it simply means that inside the bracket 1 multiplied by this bracket, we are going to have x squared plus x plus 1. Then we simply give the derivative of this. We are going to get 2x plus 1. So this is the final answer of this question. Our next question is based on 2016 November. Now remember, we only focus on rules of differentiation, differential calculus. Now we have this particular question, which it's saying we must find the derivative of y is equals to square root of x to the power 3 minus 5 over x to the power 3. Now how do we do this? Remember, we must simplify the fraction and also the radical sign. So square root of x to the power 3 is the same as x to the power 3 over 2 minus 5 multiplied by x to the power negative 3. Y is equals to, we derive this, we have 3 over 2 x to the power 3 over 2 minus 2 over 2. Let me quickly work out this. So we have 2, 3 minus 1, actually 2, this is 1 over 2. So 3 over 2 minus 1, it's 1 over 2, plus, no, not plus, we have our constant, and then we derive this, it's negative 3 x to the power negative 4. Then we simplify this further. Negative 5 multiplied by negative 3 is positive 15 x to the power negative 4. Actually, we can leave our answer here. This is our final answer. Suppose you want to leave it in a radical and fraction. We are going to have 3 over 2 square root of x plus 15 over x to the power 4. November. Now we are looking for the derivative of the following function. We start by simplifying. So x multiplied by 3x, it's 3x squared. X multiplied by negative 7, it's negative 7x. 1 multiplied by 3x is positive 3x. 1 multiplied by negative 7, it's negative 7. Negative 7 plus 3x is negative 4x minus 7. Then the derivative of this, we have 6x minus 4. We are done with this question. Our next question it's from the very same question paper, which is 2017 November. Now remember, we need to simplify the radical sign and the fraction. The derivative of this, we have 3 over 2 x 1 over 2. The derivative of this is positive 5x. Then the derivative of this is a constant. The derivative of pi over 2 is 0. So we have 0 here. And then plus 5x. This is our final answer. Now actually there's a problem. Let us quickly rectify it. Our problem is here. We have positive 5x to the power negative 2 plus 0. We have 3 over 2 x 1 over 2 plus 5 over x squared. If you want to, may leave your answer here, but like I said, if you wish to continue, you will have this answer. Now this is the end of this lesson video. I hope this will be helpful. This is Bahula SJ. Thank you very much.